Hello, in this video we are going to be working through example 2 in section 8.1, and example 2 deals with determining limits of sequences. So for each of the three sequences that are given here, we need to write the first four terms of the sequence and determine the limit of the sequence. So one of the reasons why I have requested that you write the first four terms of the sequence is that it can help you get a feel for the behavior of the sequence, which will help you determine the limit of the sequence. So starting off with part A, the cosine of n pi, with n starting at 1, this is going to be the cosine of 1 times pi, or just the cosine of pi. Then we'll have the cosine of 2 pi, the cosine of 3 pi, and the cosine of 4 pi, and so on and so forth. The cosine of pi is negative 1. Cosine of 2 pi is 1, the cosine of 3 pi is negative 1, and the cosine of 4 pi is 1, and it would continue from there. So that is what we need for part 1. For part 2, we need to look at the limit as n goes to infinity of the cosine of n pi. Now remember that for a limit of a sequence to exist, then the limit of that function, or the limit of the sequence, needs to approach one unique number. But in this case, the cosine of n pi just simply gives us negative 1 raised to different numbers. So we could actually write this as a negative 1 to the n. So if we think of it that way, then we need to evaluate the limit as n goes to infinity of negative 1 to the n. But that doesn't converge to anything because it's always going to be alternating between negative 1 and 1. So we can simply write DNE or does not exist. Let's go ahead and write an explanation to support that conclusion. And this is because the terms alternate between negative 1 and 1. So this means that the cosine of n pi from n equals 1 to infinity diverges. And that's our conclusion for part 2. For part B, I'm going to pick that up in another video so that I can keep these videos a little bit shorter and make them easier to watch.